There are two parts in this lesson. So Cartesian coordinates in 3D. Right. So if let's try to do that, something like that. So we have a space, x-axis, y-axis, z-axis, and then we have this point here is O, and this point here is A, and we're just going to represent it like that. So the coordinates are x, y, and z. Right, so what can we say? We say that the vector OA is for Cartesian coordinate x, y, z. And so it means that x, I, j, and k, or also that the point A has got for Cartesian coordinate x, y, z. Little example of application. So say we have 3 points, which are A, 1, minus 1, and 3. B, which is 2, minus 4, and 5. And C, which is 5, minus 13, and 11. And we want to show that they are collinear. Okay, so what do we want to show? We want to show we need to show that there exists lambda belonging to R such that AB is equal to lambda AC. Right, so what is AB? AB, the vector AB is got for coordinate 2 minus 1, that's 1. Minus 4 minus 1, that's minus 3. And then 5 minus 3, that's 2. And then the vector AC, it has for coordinate 5 minus 1, that's 4. Minus 13 minus 1, so that's minus 12. And then 11 minus 3, that's 8. So what we can see here, there is a factor times 4. Here there is a factor 4. And here there is a factor 4. So indeed, AB, sorry, actually I should say AC is equal to 4 times the vector AB. Or, basically AB is equal to 1/4 of AC. So indeed, AB and C are collinear. Now, equation of a sphere. That's going to be a bit tricky to represent. So we have, again, 3D space, x, y, z, and so, okay, so say there is a point here, O, and here there is a sphere. Right. And say, so O is the center of the sphere. And there is a point here, which I'm going to call M, and let's work on it, x, y, z. And O has got for coordinates what? XO, YO, ZO. Okay, how is the sphere defined? Well, the sphere is defined by this distance here is constant, OM. So what we can say is that OM, the magnitude of OM is equal to R, which is the radius of the sphere. Okay, so if I what is the magnitude of OM? Well, the magnitude of OM is square root of x minus xo square plus y minus yo square plus z minus zo square, and it's equal to r. If we scale both sides just to get rid of the square root, that means that x minus xo square plus y minus yo square plus z minus zo square is equal to r square, which is the equation of a sphere of radius r and center xo, yo, zo. So say, for example, example. If the center is 1, 2, and 4, and the radius is 4, what is the equation of the sphere? Well, easy peasy. It's x minus 1 square plus 1 minus 2 square plus z minus 4 square is equal to 4 square, which is 16. That's the equation of the sphere. Another kind of problem could be, so you are given, say you are given this equation here, x squared plus y squared plus z squared plus 4x minus 2y plus 6z plus 4 equals 0. So, okay, what's the center and what's the radius? Okay, so we just need to group the x terms together. So the equation becomes x squared plus 4x plus y squared minus 2y plus z squared plus 6z, and then the term on the constant term goes on the other side, minus 4. Now we just need to complete the square for this bit. So that's what? X plus 2 square minus 4. Then for this bit, that's y minus 1 square minus 1. And then for the last bit, that's z plus 3 square minus 9 equal minus 4. We move all of the constant term on that side, so that x plus 2 square plus y minus 1 square plus z plus 3 square equal, okay, so that's what's that, minus 4 plus 4, and then that's 10, which is root 10 square. So that means that the center is minus 2, 1, minus 3, and the radius is root 10.